All right, everyone, is 201. So my name is Phil Belcastro. I'm a customer applications manager here with Mintek Resources. Been around Lime for 15 years, coming up soon. And today we're going to talk about Lime for soil stabilization. So it is well known that Lime is really great at drying, modifying those clay soils, drying those wet, troublesome soils, just causing a lot of trouble on the site, modifying those high PI, high clay content, nasty soils. Well known that Lime is really good at those things. But today we're going to talk about Lime for soil stabilization. We're going to focus on the true strength that can last on that project. So here's our agenda today. We're going to talk about take a quick little trip back in time, then bring it right back to the present. So then and now, we're going to look at some stabilization specifications, real high level stuff, before we start looking at some of the science behind Lime stabilization. And then we're going to get to some data, some case studies, internal, external, things like that. So the majority of the time we're going to be together, we'll talk about that number 4 there, the case studies and the numbers and the data. So lime has been used for a long time. The Great Wall of China used a sticky rice mortar made of lime and rice flour. Sticking with China, there's these burial pyramids were constructed with clay and lime. They were discovered about 5,000 years ago, so who knows when they were originally constructed. And since I mentioned pyramids, yes, those pyramids that I'm sure in your mind, they use lime as well. On the road side of things, the Romans used lime in their sub-bases dating back more than 2,000 years, and realistically, the practice probably existed in that area long before road construction began. So the use of lime in construction is nothing new. So all these quick examples on the history side, there where lime was used for strength. You know, we were providing the source of calcium to develop those bonds with the silica and the alumina. So lime plus volcanic ash and water is going to give us a concrete material. So that's exactly what we're going to talk about today is lime from Mintek, pozzolans that are either in those clay minerals or supplemented with calciment LKD, plus water is going to give us strength. And real quick, the topic of ancient concrete, I just came to my mind that I might as well include that it's an interesting topic, and recently, people have been finding out what is making it last the test of time. Spoiler alert, the secret is lime. So we did a nice little article on our website if you want to check it out, talking about how those ancient concrete, those ancient structures use lime and are still standing today. So we know that today's projects, they demand strength. Whether it's the building pads and parking lots associated with all those data centers and distribution centers that we need, airports that are loaded with precious passengers, cargo, roads and rail, you name it, chances are our material has been on there to stabilize it. So many count on lime stabilization. So here's the DOTs that we work with, and I realize this is a pretty busy slide, so we'll go ahead and move on from it. Unfortunately, the next one is just as daunting. So my point of this slide is that each state has their own criteria. And maybe you have your own geotech report you're looking at. Maybe you are a geotech. Feel free to reach out to us. Happy to go through those specs. Maybe point things out that are great. Maybe point things out that maybe we could challenge or talk through at least. So feel free to reach out with any specification help on the not just stabilization side, soil modification. You got some troublesome soils that someone's telling you need to be removed and replaced. Well, maybe we can find another answer. And we did take the best of the best to create our own stabilization specification. This one, again, is up on our website, or feel free to reach out. We can get it to you. But like I said, best of the best here. Took what we really felt was an all-encompassing look at a stabilization spec from a lime producer point of view that knows lime in and out, and put it up here. And with that, look at that, a couple minutes in, and we're already on to number 3. So let's get technical. So there are many great references at your disposal on this topic of lime stabilization. including more great things on the Mintek website. So I think that's my last plug for the Mintek website. But on the right side of the screen, the NLA, National Lime Association, has really good documents as well. But a lot of these documents on the side of the screen come from that blue book right in the middle. And when I was building this presentation, I'm looking on the internet for a picture of this book to highlight, and they're all pixelated when I blow them up. And I'm thinking, what am I doing? I have one right beside me. So here it is. First time Mintek Resources presents webinar where I'm using a prop. So I was thinking about making it, why not use this? So that's my kitchen counter right there. Yes, I have my Mintek hat on. And a lot of these references and a lot of this technical information is coming from really what I refer to as the New Testament of the Lime Bible. The Old Testament being what I call the Boynton book. This is chemistry on and technology on lime and limestone, where this is Dallas Little's book on stabilization of pavement subgrades and base courses with lime. So a lot of really good stuff in here, and we'll pull some of that out right now. But all this stuff is, the research is out there. There is data. We have the soil samples. We have our folks out there doing it and seeing the benefits. So with that, in that blue book, one of the quotes I pulled out is basically this, that many clay soils are reactive. In fact, lots of them are very reactive with lime. They're going to form these stable compounds, the calcium silicate hydrates and calcium aluminate hydrates, and they're going to bind those soil particles together to provide long-term stability. So calcium coming from the lime, silicas and aluminums from the clay, or supplemented with our calcium LKD that has some of that in it, some of that pozzolanic properties, and they're going to bind the soil together to give that long-term stability. A couple more quotes out there. So basically, these are saying that the soil provides the pozzolan, like I just said. The lime, we're going to increase the soil pH to the point where we're going to make those naturally occurring pozzolans, silicas and aluminums that are locked up in those clay sheets. We're going to make them available for these cementitious calcium CSHs, CAHs. So this is a SEM image right from page 48, I believe, of this blue book, where we can literally see these reactions happening. So bluntly, lots of times lime is only getting half credit. Like I started, lime can dry. It's going to modify those clay soils, but lime can gain strength as well. Got all these resources at our hands. We've got the data that we're going to show at the end of this and beyond. We have the equipment. Here's some SEM images. We have an SEM right down the river. Downtown Pittsburgh. Our lab is right down the river. We have this SEM. We're getting an XRD, which is something we'll talk on in a little bit here. And so lime stabilization is not necessarily anything new, but it's something that trying to bring to the forefront and let people realize it's a great tool in the toolbox. So one thing about lime stabilization is in our lab, lab testing is important. We want to see at what point, what dose rate can true stabilization happen, and what does that stabilization look like for us in the lab and translate to the field. So often we run EADS Grim or ASTM D6276. So if you were to hop on the Google machine and just type that in, chances are the first video that's going to pop up is right there on the right side. So that's Steve Satoki from our lab, a couple years younger, but hey, this is one of the methods that we run all the time. Sometimes if we, for one reason or another, would want to skip that test, maybe we would do increasing dose rates of lime just to see how that strength looks on for us, whether that be on unconfined compressive strength or CBRs. And advantage, disadvantage both. Lots of folks who use UCSs, CBRs are useful because we can also look at the swell. So how well is that soil modify, mitigate, shrink swell? So regardless, proper testing is needed for lime stabilization. Drying side, got a wet site, give Mintek a call. We'll get a truck there as soon as we can, help you dry up that site. Modification, hey, I got a high PI soil. How far can I drop that PI? Okay, we can do some testing, but stabilization, we want to see at what point we're going to achieve true stabilization. And the benefits of lime stabilization are many. You could probably guess most of these, but we'll kind of spell it out a little bit. So on the increased durability, so that's resistance to erosion and improved load-bearing capacity. Those are permanent strength gains that are long-lasting, and in fact, they continue to improve over time. Show some results, some data with that. So as long as those ingredients are present, we're going to keep gaining that strength. Autogenous healing is an awesome term you can throw around, but it's a pretty neat natural process where the lime-treated soil can repair itself over time. The higher structural layer coefficient, so parameter in pavement design, for the looking at how it contributes to the overall structural capacity of that design. We're going to lower the moisture absorption, so we're going to reduce the ability to take in and retain water, which is critical for improving the soil's performance and stability and durability. And that goes right hand in hand with that last point there, freeze thaw. So the ability to withstand those tough, harsh freezing, thawing, freezing cycles without losing that any significant strength. So our first look at some data, looking at CBR's California bearing ratio, confined penetration test. So there's a couple things going on here in a couple different colors. Red is our untreated CBR, low values, 9.428. So low values here, wouldn't want to build a sidewalk on this, let alone a highway. And then if we look at the next column over, the purple, that's the CBR where we've lime treated the soil, we've compacted in our mold, and essentially immediately, within a couple hours, have done our penetration testing. So that increase is from soil modification alone, the calcium interacting with the clay particles, molecular flocculation, agglomeration, edge to face, all these sort of things that we can talk about another time. But this is essentially immediately on the modification side. But today we're going to focus on those green bars. So the change from the red to the green is large in many cases. And you can see the soil types we're looking at. Primarily clay, some fat clay, lean clay. So nasty things probably to have on your site. Probably not very excited to see it. I'm one of the few people that are excited when I go on these sites to see that clay soil because I know that we can help you out. Look at that, we're zooming through. So onto the case studies. If you've seen any of my presentations, I've highlighted these two in the past, so I'm not going to harp on them for too long, but I like to read about lime, and I mean, who doesn't? I'm sure you do since you're on this webinar. So in Louisiana, I looked at a study that was essentially a study of a study. And a couple hundred pages, I'll distill it down for you. It concluded essentially this. So this is a slide right out of one of my other presentations. So it concluded that lime stabilized subgrades overperform non-stabilized subgrades. I hope you realize that by now. We're going to gain some strength. They're long-lasting, so they are permanent. They're not liable to leaching. They're suitable for a PI of 10, so that's something that comes right out of this blue book. But it's also something that we challenge at times. In fact, one of our case studies where we saw some really good results with a PI lower than 10. And another general criteria is clay content at 25%. So we'll see one in a little bit where we were below both those thresholds and still got some great results. And then finally, they're accounted for in many pavement design criteria. Not all, but 0.1 is a pretty conservative number that lots of folks use. On the other side of the screen, that's a North Carolina study, pretty neat study where they built pens looking at different remove and replace options, bringing in aggregate, some select fill, and also one of them was lime treated soil, lime stabilized soil, excuse me. And not too surprisingly, lime stabilized soil, at least not surprising to me, or maybe not surprising to you since I'm talking about it, lime stabilized soil outperformed the others on many fronts. So cycles to displacement, so cycles to failure, and also on the cost side. So this is one we've highlighted that we can save about a third to a half the price of remove and replace if we can treat what is there in the soil. And this isn't even taking into consideration the additional savings on the local roads. Think of all the stones being hauled in and out and things like that with the abuse on the road. So it's also just a couple of truckloads of our material, treat that in situ soil, treat the problem those you were dealt with, and move on. But maybe a little curveball for any of you who have been on mine before. One that I want to highlight today is one in California. So I've had this one in my back pocket for a while now, and wasn't sure when I would talk about it, but whenever we got our minds together and started talking about, hey, we're not getting not our fair share, which just folks don't seem to be understanding that lime can gain strength, permanent stabilization. This one kind of popped in my mind. So this is a canal in California, the Fryon-Kern Canal. I believe I'm pronouncing that correctly. Forgive me if I'm not. But it's a great example of the efficiency of lime treatment, even in harsh hydraulic conditions. So it was originally constructed in 1945. That's about when that picture in the middle was taken. Completed in 1951, and it conveyed water to areas like Fresno. From what I understand, wasn't there. A third of it was built on high PI expansive soils that resulted in shear failures and even concrete failures along some of the linings due to heaving. The schematic on top, 1 year later, they're seeing slope failures. So in the 1970s, the Bureau of Reclamation said, hey, you know what? Enough of this. Let's fix it. They decided to repair those failed sections using lime. So here we are in the process. Is how they did it. I thought this was kind of neat pictures. They moved material down to the canal bottom to spread the lime and mixing, and do a little mixing, little quotes here. Using disc harrows, fine for the time, great. And we'll talk about equipment a little bit later, but still a pretty neat process that they did. My favorite picture is here in the middle. They compacted using the world's biggest yo-yo, at least biggest one I've ever seen. And turns out a dose of 4% quicklime reduced the PI from a 47 all the way down to a 12. So pretty impressive just on the modification side. But we're talking about stabilization. So that fellow there on the right is pointing to the imprints that are there after 10 months in the water. You figure there's flow, hydraulic conditions, pretty harsh environment, and it's pretty neat to see that no erosion had happened on that. They did end up taking some UCS core samples 1 month later, and they found that that lime treated soil had already gained 320 psi, and a year later they did some more core samples, and they were up to almost 500 psi. So that's a UCS increase of almost 20 times. So they also realized that these lime stabilized lines, they need less maintenance, so they eventually said, hey, this additional aggregate that we were maybe going to put on some of these sections is not necessary, which resulted in about $60,000 in cost savings. And that's in 1984. At least that's when that rehab finished. So looking at inflation numbers as the obvious, inflation expert economist that I am. Anyway, I did some Googling, and $60,000 in 1984 would equal about $180K today. And if we took that all the way back to the start of the rehab date, 1975, that same $60,000 would be over $350,000 in savings. So just from realizing, hey, this lime stabilized soil is doing its job even better than we thought and getting nice and hard, we don't need to line this with some aggregate. Just a couple more pictures from the studies that I was reading about. So on the left side, it's more of the sheath foot imprints that you can still see. This is saying 1 year later. And then this is a 2010 photo on the right, and depending on how large it is on your screen, you can still see some of those dimples in there. So pretty impressive. And then you might be wondering, well, what's going on in the background of that picture, or at least on the right side, background is mountains. That is not a lime treated area. They had some rock on that side. So it's just neat to see minimal erosion. Those pad foot roll imprints are still there years and years and years later. So just with that, you thought we were done being overly technical. This is a pretty cool slide, though, I must say so. XRD, X-ray diffraction, which is a technique we use in the lab to identify different crystalline structure materials. So in lime stabilization, XRD can help us determine mineralogical changes and the formation of new compounds. So this XRD pattern showed that the lime treated soil indicated the presence of different minerals like calcite, but maybe more importantly, or maybe not more importantly, but also the absence of others like smectite, which is, the expansive clay we were battling at the start. And then in the middle, TGA, thermogravimetric analysis. TGA have one of these in our lab as well. We look at the weight change as it's heated. We use it all the time to look at what is the composition of this. What's the carbonates versus oxides, or how much of this is hydroxides. So the peaks can tell us different things, and here we can use it to confirm the presence of different materials and minerals like the CSH, CAHs, those needle-forming cementitious compounds. On the right, the optical analysis, a higher absorbance intensity is a direct function of turbidity, and you can see a clear drop in the turbidity of the lime-treated soils, which is indicating that the dispersive nature of those native soils was controlled, so making them less prone to erosion, which is essentially why we can still see those imprints of the pad foot roller, or sheep's foot, excuse me. So to wrap up on this one, hey, initial construction, 1945 to 51, cool picture there. That one's just, I think it's really neat. Reconstruction, 75 to 77, got that lime in there, get things shored up, and in one of those studies, hey, 5 years later when they did the study, things were looking good, no failures, and we're still talking about it. There's a nice color photo finally. This is right from the website just the other day. You can see the earth line segment still standing strong today. So lime stabilization needs to still standing strong. So some of those nostalgic photos made me think about equipment. So a real quick piece on that. So then versus now again. Spreading with dumps, sure, we still have folks doing it. There's a time, there's a place. And then before we also saw them kind of mix it in a little more rudimentary. So now, if we can use these spreader trucks to really dial in and get a nice even layer of lime, exactly how much we want it, where we want it, and then maybe even more, maybe not more critically, but at least just as important is the proper incorporation. It's going to help us minimize the mellow periods with the proper and complete hydration with those modern soil reclaimers. So if you can, I encourage you to use this other equipment. However, I realize there's a time and place for dumps, super sacks, mixing with different yellow iron like dozers and even excavators. So that's all I'll say about that. So some pretty neat photos. Okay, so hop into some of the data that we've done in our lab. So this is a 2012 project down in Louisiana that sort of shows what I was talking about, where that strength gains over time. So our 1 year UCS there is great, almost 400 PSI. So yeah, really solid there. But we're not going to wait a year to get on it. So the 28-day mark is still something solid. We're well over 150 PSI. I'll speak later to 125 PSI mark that I'd like to get out for the UCS. So right at that for 28 days. And that's not to say that before that modification didn't help us get on that soil and keep construction activities happening. On the right side, CBR, untreated, super low. Don't know the value. Probably looks like a 5 or a 4. On the right side, no cure. So once again, essentially only from modification alone, getting up to already 30. So yeah, nice and solid there. But the higher, once we've cured it to show what it does over time, that higher green CBR value is another testament to lime gaining strength for true stabilization. This is a typical graph that I've shown time and time again. It was a study we did in our lab using 11 different soils. So we averaged them together. And just tells a story of how cement is a sprinter, rapidly gains those strengths and then tapers off over time, where lime is a marathon runner. Not gaining the strength quite as fast up front. Hopefully modification can help us get on the site, but the true value, that strength that can be realized, is with time. As long as those ingredients are there, calcium from the lime, high pH from the lime, pozzolans from the soil, clay or supplemented from the calciment LKD, and some water are going to help us gain those strength and keep gaining that strength over time. So, but what I encourage people to do is to understand that marathon mentality, that testing should be used to accurately show what those reagents can do. Because every once in a while I fight a battle where someone is looking for 2-day numbers at ambient cure conditions where lime stabilized soil is just not going to show its true colors. You're not really giving it a fair chance to show what it can do. So you're essentially looking at it and it might fail, but realistically it might be a solid soil for you down the road. We talked on autogenous healing. I couldn't find the actual data, but I have a study somewhere in the archives where we did unconfined compressive strength testing and we just broke those cylinders, wrote down the value, put them back on the shelf for a while, and a couple of days later, broke them again, and we saw that strength continue to gain and gain. So that just shows as long as those ingredients are there, we're going to keep gaining that strength, just like that Roman concrete, stay nice and strong. So before I hop to Virginia, I tried to grab data from throughout our network. So essentially east of Mississippi, so Iowa to Florida to Maine to Louisiana and everywhere in between. So it's great. It's really interesting and exciting to see how different but similar those how lime can work, and just it's stabilizing the soils throughout our network. So here in Virginia, we got a couple. I was with our Eastern sales manager, Jim Gay, and he says, Phil, come on down this site. We got a fat clay soil. I want to see what this stuff can do. But while you're down there, I don't know, something about it. I'm curious to see what this sandy soil does. So I went down there, grabbed a couple samples, the one tested as a fat clay. The one that our customer pointed out said, there's our sand. Yeah, grab a couple buckets of that. Well, that turned out to be a high plasticity silt. And then while I was on that site, I was talking to the inspector, and he said, that's not the sand. The sand's over there. So I had one bucket left. Actually, I didn't. I dumped out one bucket. Went and grabbed one more bucket of that. So that one tested to be a silty sand. And I don't have the full workup on that. That's why I'm missing a chart on the bottom. But you can see pretty much across the board, we got some solid numbers. And I mean solid, some strong numbers. That fat clay soil, 3%, 175 PSI, 5%, we probably don't need that sort of strength, but if you want it, it's there. The high plasticity silt performed very well as well. So a little small on my side, but that PI is a 13. Okay, so that's not the one I'm looking for. Must have been that sandy silt, 16% clay. And I believe that tested as non-plastic. So that kind of challenges some of the things that are in there. And I understand why they're in here. They're kind of in general. Lime conducive soils are generally soil with PI of 10 or above, or 25% clay content. So I encourage you just to do the testing. Reach out to us if you want to try to prove out the solutions, because this is one where this one might not have been considered for it, but we showed, hey, lime can be used for not just your fat clay soil that was targeted for, so we're building lift after lift, but also that sandier soil that we have over there that we're going to maybe work in as we go. It's an interesting click. Wasn't worried for that. I must have put this in here thinking, hey, this is generally where we see the different chemical reagents used. Cement has its place, of course. Generally, the sandier, coarser grain materials. As you move to the right of this chart, higher PI, higher clay content. That's where quicklime really shines. But we just showed how, hey, it can work in the middle too. But that calciment LKD is a nice one to bridge the gap between those two as well. You can see we've recently added our CQL, another exciting product we're proud about, much finer than traditional quicklime fines. So we can go on a whole tangent about the different benefits, additional benefits of that quicklime sizing. All right, in North Carolina, this was an interesting one where we were working through a cement shortage. We got our hands on some soil, helped our customer. She didn't have nearly enough cement to treat all the different soil types she had. So she said, hey, Phil, test this, see what lime can do. And turns out that 2 of the 3, hey, save your cement for the number 1 over there. The other 2, solid performer, 3%, 5%. You can see the strength there. In fact, the one on the right, maybe you can even dial down that dose rate to get something to save a little bit of lime even. But it was really interesting to see, or be able to, not interesting, it was really nice to be able to relay that savings to the customer. And that savings is, hey, use the cement where you need it. We've got this American-made product we got plenty of. Use the lime where you can. And this was spec cement from the start, but they couldn't get their hands on cement. So it was a little eye-opening to the engineer that when they thought, hey, I need some strength for this project, I need cement then. Well, we did testing, we had conversations to show them that we can get this true strength, true stabilization using lime. So kind of open their eyes to that and open other projects in North Carolina to lime as well. So just a couple more where lime is a very, very good performer. Moving around our network, Indiana. This one, hey, we needed some true stabilization. We did Eads Grim test, ASTM D6276. We found that at 3%, we're at that 12.45 pH mark. Boom, that's where we need to be for stabilization. So now we know 3% quicklime. Let's go back in the lab and let's see what sort of strength we got. Hey, beat that 125 PSI that we were looking for, did the proper lab testing, confirmed it with strength testing, and saw that the lime could gain strength there. Sorry, I was thrown off. I saw a question or at least a bubble in my chat. So I think I mentioned that before. If not, you can throw some questions in the chat and Leanna might be able to relay them to me to answer live here, or we'll do some Q&A at the end and we can try to take folks off mic if the technology works. Ohio, do a lot of work in and around Columbus area. A little bit outside that, Cambridge, Ohio. So we got some real nice stabilization with 250 plus PSI, but we had the added benefit of soil modification. So when I've spoken modification so far today, I've talked about what I haven't talked about at least is the net benefit. So we're going to increase that OMC. So that means if you have a wet soil, say 20-some% moisture, here look at this data, we don't have to dry it all the way back to 16, 15%. At 3%, 4% quicklime, that OMC is higher, so we don't have to dry it back as far. We can hit 18, 19, maybe even 20% and still have that soil where we want it for compaction. This Columbus, Ohio soil, we elected to do some CBR, so we were interested in shrink swell mitigation as well. So some really great CBR increases. So we've talked about some nice CBR increases already, but this one was more of a reminder for me to talk about a neat story had with the guys over lunch the other day. They reminded me that this project, the plans changed. They needed to cut a few feet in some areas where the soil was already lime stabilized, and the dozer blade was actually skipping off and sparking on that lime stabilized soil. So they literally had to rip the soil with a scarifier to be able to get, move the elevations around and get the building where it needed to be. But that was one of those where I was talking, I was like, man, I'd love to have a picture of that. So just a neat story where lime for strength is happening. Shifting gears a little bit to Illinois. This one was a cold day. So we benefited from the exothermic reaction, hydration reaction. So we got some heat rise to help things cure as they would in warmer conditions. But we also were giving them options. This was another cement shortage. So we said, hey, Norm over there, our salesman in the West, said, hey, I've got our cal cement product. I've got some quicklime. Let's do some testing and see what it can do. So it turns out this one, the cal cement did a really good job. Quicklime, really good too, but the cal cement might have been the answer for them. And then it's just working on pricing, availability, things like that. But lime for stabilization happened over there outside Chicago. This one I've highlighted from time to time. It was a neat one. It was one of the first times ODOT used cal cement LKD to stabilize an embankment. So the picture on the top right, you can see some water. We were out of room. We couldn't just make less of a slope. So that's when they brought in the lime product to stabilize that soil and get it back to the same slope it was. And it was a really neat soil product to be on, just as they kind of worked through those issues, and we were there to help out. Virginia, this one always sticks in my head. I just like the name they gave it, the Fred X. I thought it was catchy. But it landed right at those typical dose rates for modification. Usually around 4%. We've shown a couple of 3%, but anywhere from 3 to 5, 6%, 7% is probably high, but that's where the dose rate usually lives for lime stabilization. And that's dose rate on dry weight. It's how I tend to look at things in the lab. But like many of your projects out there, problematic soil, sound familiar? Tight timeline, people want it done yesterday. Probably all the money you need, right? Or is it a tight budget? Probably. So kind of copy and paste for a lot of these case studies would look like this. Tight timeline, saving the dollars, bad soil we're dealt with, what can we do? Lime stabilization. Hopping back to Virginia for a moment. Again, This one, we immediately improved that working table. Once again, Jim was on the site. It's like, what are these guys doing? He ended up talking to them. He grabbed a bucket of soil so I could show them what it could do. But he got them to load a line where they were able to modify that soil, pass the proof roll, get the constructions operations going again. And then we came back to them later with we just did a quick cure at ambient conditions for one reason or another. So that's why we were at about the 120 psi mark. But we were able to show them like, hey, we're going to see some stabilization here. Use it to dry up that site, get that spreader truck out of that junk, turn it into something that is much more usable, more friendly for the guys, more stable, and then you're going to gain the strength over time. This one popped in my head when I was over in California last week. I was at a FDR and Soil Stabilization Committee meeting. So with FDR in my mind, it came back to this one, which is one of the first FDR projects many years ago where people were literally flying in from all over the world to check it out. So did a lot of cement for the binder, but in some of the areas they were using the Cal Cement LKD to really help to bind things up. So right product for the right project at the right time. And so I wish I could go back a couple of clicks. Maybe the comment that's in there, I was talking to someone at that ERA conference about this presentation, said, hey, make sure you look at things in those harsh conditions, those soaked conditions. So touched on it with that canal case study, but I'm tempted to do a bunch of clicks back. If you think back to that first 365-day study, there was two lines that were essentially right on top of each other. One was the soaked condition. So it's just another feather in the hat showing that lime stabilization can withstand those harsh conditions, those saturated soil conditions, without losing that strength that was gained. So if we have time, maybe I'll hop back to that. So how does your soil stack up? I tried to go throughout our network, have some stuff from Florida. I have data from Atlanta, Kentucky, Tennessee, all these sort of places, but this is already a busy slide as it is. So if you're wondering how your soil stacks up, feel free to reach out to us. So it turns out I dove another plug. This is a virtual tour we have on our site of our soil lab where we are happy to prove out the products. We'll test the quicklime. We'll test Cal Cement LKD. We'll even see how cement stacks up, help you make that informed decision whenever you're looking for true stabilization. And that's just one of the ways that Mintek Resources is proud to be just that, a resource. So already touched on the general guidelines, soil stabilization specification that we have there, lime stabilization, excuse me, where we look at mix design, material sampling, what sort of limitations, maybe that be weather, wind, things like that. How do you select that treatment? All that's in that couple-page document, or which was a hot button in this nice cold months that are hopefully behind us. Cold weather liming, people were not slowing down. I was on a couple sites this winter where it was pretty darn frigid. I give the guys credit out there working longer than me because we were able to keep that work going in those cold conditions. So this and more are on the site under the resources tab. Check it out. If there's something in there you're curious about that we don't see, reach out, but please use this as a resource. We pride ourselves on being much more than just a material supplier. We look to be a partner. We look to be a problem solver. So feel free to reach out to help us help you. So that will open up for the Q&A. I'll probably stop presenting so I can check out what's in the chat window here. Put your chats, any questions in the chat, and I'll see if I can unmute anybody if you raise your hand or something like that. All right. The one in the chat was Leanna reminding us to submit questions for the Q&A session. So something that she reminded me to remind you of, and I obviously didn't. So if you have any other questions, now's the time. Let's talk through them. Like I said, happy to see what questions you got. Curious to see what questions you got. We'll hang out for another minute or so, and hopefully we can have some nice lime time talk. It's very thorough. Listen, thanks for your time. If you think of something, please reach out. got a question that you didn't think of for whatever reason, reach out, work through it. Thanks for joining. Keep in mind how lime can help stabilize your soil, give it that long-term permanent strength gains. And I see in the chat someone added the that does look like the document I was looking at for the Fount Kern Canal. So yeah, thanks. Does Mintek help with getting material to a site? Yes. I don't think I maybe understand the question completely, because that's definitely what we do. So are you wondering, are you looking for loads of lime, loads of LKD? We help with trucking, yes. Some folks have their own trucks, that can help sometimes. So yes, so please reach out. Hopefully through this, you have someone's email somewhere that we can get you connected with someone to get material to a site. Yes, absolutely. No further questions. I'll hang on for another minute. Thanks again, everyone, for joining. Keep an eye out for the next one. If you got any ideas for topics, we're always open. So thanks. Have a good one. Stay safe out there.